In this video, we're going to take a look at addition and subtraction, and we're going to do that based on place value. So we think about place value, one of the first things that comes to mind are our place value blocks. So if we were working with adding and subtracting with place value using the place value blocks, that would be a concrete manipulative. In this video, we're not going to work in the concrete. We're going to move into a representational stage, which means that we need a way to represent these blocks pictorially. So we're going to use a square for 100, a line or a dash that represents our rod of 10, and then we're going to use a circle to represent a 1. So the reason that I wanted to bring that up at the beginning is that we're not going to use a small square to represent a 1, even though it looks more similar to that, because we may or may not need hundreds in the problems that we do today, but it's going to be important that students know right up front that when they run into hundreds, they're going to need that square, and when they're talking about ones, we're going to use a circle for that. So let's go ahead and take a look at a couple problems using a representation of our place value blocks to do some addition and subtraction. For the first problem, we're going to add 21 and 34. So the questions we have to ask ourselves in the first number is how many tens? I have 2 tens, so I'm going to draw 2 tens, and I have 1 1. So this is the representation of 21. In my second number, I have 34, so I'm supposed to add on 3 tens and 4 ones. Now I can count those up. We always double check, can I make a set of 10? And I can't, so I have 5 ones. And when I add up my tens, or count all my tens, I have 5 tens. Now, 5 tens have a value of 50, and 5 ones have a value of 5. So when I put those together, I know my sum is going to be equal to 55. And essentially what we've done is decompose both of these numbers and said, think about 21 as 20 plus 1, and think about 34 as 30 plus 4. Now we can add our ones, we can add our tens, and we can recompose that number then based on place value. So that's how we would add a number like 21 and 34. Let's take a look at a second example. In this example, we're going to add 16 and 47. So we want to show the number 16. To do that, that's 1 10 and 1, 2, 3, 4, 5, 6 ones. And I'm going to add to that 4 tens, 1, 2, 3, 4, and 7 ones. 1, 2, 3, 4, 5, 6, and 7. And one of the things you'll notice is that as I made my ones, I only went out to 5, and then I went to a new line. So what I've done for myself is created a real nice and easy way for students to see that, hey, I have 10 ones here, and that's going to give me an extra 10. So this is setting up that idea of carrying. So now that I've taken 10 ones and given myself an extra 10, I can count 1, 2, 3, 4, 5, 6. That's 6 tens, which have a value of 60. And 3 ones, which have a value of 3. So when I add those back up, or I recompose those numbers, I'm going to get a sum of 63. If we went back to the algorithm and took a look at the algorithm, what we would normally do is say 6 plus 7 would be 13, and then we would come up top and carry that 1, and that's where the carrying happens. This 1 that's being carried is shown in these 2 steps over here, where we actually reform a group of 10 ones and give ourselves an extra 10. And then we would see that we had 5 and 6 tens, and we'd keep that in the tens column so that we could show it had a value of 60. So that's what addition and subtraction looks like, or addition looks like with 2-digit numbers. Let's take a look at subtraction. We're going to be using the same symbols for our hundreds, tens, and ones. And in our first problem, we're going to do 36 minus 12. So I need to show my first number, 36. That's 3 tens and 1, 2, 3, 4, 5, 6 ones. And I'm supposed to subtract off of that 1 10. So the first question is, can I subtract 1 10 from my 3 tens without using negatives? And yes, I can. And then can I subtract 2 ones from my 6 ones without using negatives? And yes, I can. So I'm already ready to do my subtraction. I'm supposed to subtract 2 ones, and I'm supposed to subtract 1 10. And that's going to leave me with 2 tens, which has a value of 20, and 4 ones, which has a value of 4. So now when I recompose those numbers, I'm going to come up with a difference of 24. What we normally have kids do in the abstract over here is say when we subtract 6 ones minus 2 ones, we're going to get 4 ones. And 3 tens minus 1 10 is going to give us 2 tens. And so you can see how there's a direct connection between the way we're dealing with the representation and how we're working in the abstract algorithm. Let's do one last example. In this one, we're going to start with the number 41, and we're going to subtract 27. So I model my first number, 41, has 4 tens and 1 1. And I'm supposed to subtract 2 tens, which I see I can do here, and then 7 ones. Well, I can't cross out 7 ones. I don't have them. So to create those, I'm going to get rid of one of my tens and give myself 10 more ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I can still subtract my 2 tens, and now I have 7 ones over here that I can subtract. So I can go ahead and subtract 7 ones. There's 5, 6, and 7. Subtract my 2 tens, and I'm left with 1 10 and 4 ones. 1 10 has a value of 10, and 4 ones has a value of 4, so I know my difference is 14. What does that look like abstractly? Well, normally what we would have students do is go through and say, okay, I have 4 tens and I'm supposed to subtract 2 tens. Can I do that without using negatives? Yes. I have 1 1 and I'm supposed to subtract 7 ones from that. And I can't do that without using negatives. So I'm going to take one of my tens and give myself 10 more ones. And that's what we saw over here, that regrouping process, when we took one of our tens and crossed it out and gave ourselves 10 more ones. That's why we went to 11 ones, so that we could then do 11 minus 7 to get our 4, or 4 ones. And then we had the 3 tens that were left over, and we subtracted 2 of those, which gave us 1 10 left in our final answer. So besides using the place value blocks, which are beneficial to kids, we can move them into a representation of the place value blocks. And to do that, and allow them to draw pictures to model the algorithms, we can use these symbols. And then the big question that sticks with addition is, can I form a group of 10 after I've done the addition? And then conversely, with subtraction, am I going to have to reform a group of 10 or do some borrowing between one place value and another before I can do my subtraction?